Starting with the firm's production function, we can actually calculate three important production concepts: TP, MP and AP. Total product, marginal product and average product. Let's start by understanding the first, the total physical product, TPP, or for convenience, total product or TP, which is just the total amount of output produced in physical units such as bushels of wheat or number of shoes. Suppose we vary a single input and keep all other inputs constant. Then for different levels of employment of that input, we get different levels of total output from the production function, right? Let us see how total product responds as the amount of labor applied is increased. This relationship between the variable input and output, keeping all other inputs constant, is referred to as the total product of the variable input. So, if we're talking about labor input, we will talk about TPL, that is total product of labor. TP is the sum total of output produced by all units of a variable factor along with some constant amount of the fixed factors used in the process of production. Let's consider that in our shoe factory, L or labor is the variable factor and capital or K is the fixed factor. Assume also that along with some constant application of the fixed factor, say 1 or 2 machines, Shyam, the producer, is using 1 through 6 units of the variable factor. Let the resultant output be 10, 12, 15, 12, 10 and 6 units of the commodity corresponding to each unit of labor used. In such a situation, TPL for Shyam would be adding all these together up, that is 65 units of the commodity or shoes. To express this algebraically, in a production function, let's keep factor 2 constant, say at the value of x2 bar, and vary factor 1. Then for each value of x1, we get a value of q for that particular x1, x2 bar combination. We can write it out in this way. Q is a function of x1, x2 bar. This is the total product or TP function of factor 1. Let's again look at the table. Suppose factor 2 is fixed at 4 units. Now in the table, let's look at the column where factor 2 takes the value of 4. As we move down along the column, we get the output values for different values of factor 1. This is the total product of factor 1 schedule, with x2 equal to 4. At x1 equal to 0, the TP is 0. At x1 equal to 1, TP is 10. At x1 equal to 2, TP is 24 units output and so on, right? This is the TP schedule for factor 1. It is also sometimes called total return to or total physical product of the variable input. Once we have defined the TP, we can define the concepts of average product and marginal product as well. They are very useful concepts that help us understand and describe the contribution of the variable inputs to the production process. Once we have the total product, it's easy to derive the marginal product from it. Now recall that the term marginal in economics means extra. The marginal product of an input is the extra output produced by one additional unit of that input while other inputs are held constant. In other words, we can say that marginal product of an input is defined as the change in output per unit change in that input when all other inputs are held constant. When factor 2 is held constant, the marginal product of factor 1 is MP1, which is equal to the change in output by change in input, or delta Q by delta X1. Suppose factor 2 is fixed at x2 bar. With x2 bar amounts of factor 2, let's say x1 units of factor 1 produces 20 units of output and x1 minus 1 units of factor 1 produces 15 units of output. We say that the marginal product of the x1th unit of factor 1 is the difference between the output with x1 units and one with x1 minus 1 units. So MP1 would look like this, which is nothing but TP at x1 units minus TP at x1 minus 1 units, which is 20 minus 15 units of output or 5 units of output. Thus, MP refers to change in TP when one more unit of the variable factor is used with the fixed factor remaining constant. Let us see this with some numbers now. Let's say that output increases from 40 to 45 units when the input of labor is increased from 5 to 6 units with input capital remaining constant. Then TP equals to 45 at 6 minus 40 at 5. That is MP equals 5 for the 6th unit of labor added. Likewise, MP of 10th unit of L would be TP of 10 units of L minus TP of 9 units of L. Or MP of first unit of L would be TP of 1 unit of L minus TP at 0 units of L. Generalizing it, we can say that MPN equals TPN minus TPN minus 1. If you have understood the technique of estimating MP like this, you should be able to understand the fact that by adding up MP of all units of a variable factor, we again get TP. So TP is sigma MPI, where I goes from 1 to n. So to sum up, MP refers to change in TP when one more unit of the variable factor is used, the fixed factors remaining constant. TP is the sum total of MP corresponding to each unit of the variable factor. For any level of employment of an input, the sum of marginal products of every unit of that input up to that level gives the total product of that input at that employment level. Note a couple of features about the MP here. Inputs cannot take negative values, right? So marginal product is undefined at 0 level of input employment. Second thing to note is that, can MP be negative? Yes, MP can be negative in certain situations, particularly when there is excessive employment or disguised unemployment, as in some public sector undertakings in India or in some farms in India. Excessive employment of workers more than what is required, reduces overall efficiency of all the workers, because of which MP may be negative. In such situations, TP actually increases when some workers are withdrawn and decreases when more workers are added. The final concept is the average product or AP, which is just the TP or total output divided by total units of input. Average product of an input at any level of employment is the average of all marginal products up to that level as well. So AP is output per unit of the variable factor. So for labor input, it would be calculated like this. APL equals TPL by L. So if TP equal to 40, when 5 units of labor were used, then AP equals TP by L, or 40 by 5, or 8 units per output is the average product of labor, or APL. We can say that AP in effect refers to physical output per unit of the variable factor used in the process of production. In our main example table, if we keep factor 2 constant, say 4 units, we get a total product schedule. From the total product, we can then derive the marginal product and the average product of the factor 1. The third column of this new table shows that at 0 unit of factor 1, as we know, MP1 will be undefined. At x1 equal to 1, MP1 is 10 units of output. At x1 equal to 2, MP1 is 14 units of output, and so on. Let's make one more table now to illustrate the estimation of AP, MP, and TP. This table is again based on the assumption that L is the variable factor and that some constant amount of a fixed factor like K is also used in the process of production. In this, all the formulas we learned till now can be seen again. When 6 units of labor, the variable factor is employed, TP equals AP into L, which means 25 into 6, that is 150. At the same time, TP is also equal to sigma MP, which again comes to 150. What about AP? It will be just TP by L, that is 150 by 6, which is 25. And how do we get MP for the 6th unit of labor? We subtract TPN minus 1 from TPN. That is TP6 minus TP5, which is 150 minus 150, or 0 in this case. In the same way, we can repeat this process for the point at which 7 units of labor are employed. Try to find the TP, AP, and MP at this point. Now, try solving this example once by yourself. The solution would look like this. We are now going to explore a concept called the law of variable proportions. Consider Chandra's farm now. Let's suppose that land is the fixed factor for him and labor is the variable factor. And we know Chandra is producing wheat. Since land is a fixed factor, he can produce more of wheat only by using more and more of labor, right? But will every additional unit of labor employed on the same land yield the same amount of additional output of wheat? In other words, will MP of labor remain constant for each and every additional unit of labor employed? Think about it. Logically, this can never happen. If MP of labor was to remain constant, irrespective of how much labor is employed, then a country like India would have produced more and more of wheat using more and more of labor on the same piece of land. It would have never faced any food problems or the problem of unemployment. The fact of the matter is that MP must eventually diminish. A joke in economics is that if MP doesn't diminish, then it would be possible to create food for the entire world in a single flour pot, just by adding more and more of one factor of production. But why does this happen? Why does MP eventually come down? The logic is simple. Always there is some ideal factor ratio that ensures optimal production. If L and K are the two factors and K is constant, the ideal ratio can be discovered by just varying the use of L and seeing at which point MP is maximized. At the ideal ratio between L and K, MPL would be at its maximum. But once the ideal ratio is reached, any further increase would mean excessive employment of the variable factor, or it would mean lesser and lesser availability of the fixed factor per unit of the variable factor. That is, it would mean overuse of the fixed factor. Accordingly, MPL would start declining. We may ultimately even reach a point when another additional unit of labor on the same land adds nothing to total output, implying that MPL becomes zero at that point. In exceptional situations, MP may even become negative, as we discussed earlier. This is the essence of the law of variable proportions, which basically means that as the factor changes, the return to factor is variable. The law of variable proportions states that as more and more of the variable factor is combined with the fixed factor, that is, as the proportions of the factors are varied, the marginal product of the variable factor will vary. It may initially rise, but eventually a situation must come when marginal product of the variable factor starts declining. Marginal product may ultimately become zero or even negative. Now you must note here that this does not mean MP will always decline. It can increase also. MP of the variable factor can rise, but only in situations where the fixed factor is not fully utilized. If, let's say, ideally, 4 full-time workers are needed to cultivate 2 hectares of Chandra's land, MPL may increase when initially less than 4 workers were employed. MPL would be maximum when 4 workers are employed and must start diminishing when more than 4 workers get employed in the same farm. Thus, the law of variable proportions considers the possibility of a rise in MP so long as the fixed factor is not fully utilized. We will understand this better when we see the shape of the MP curve a bit later. Now, before we move forward, we should understand that the law of variable proportions is based on certain assumptions again. 1, we assume that the ratio in which the factors of production are combined can be changed. So, though it might not always be possible, we assume the ratio can be changed as we wish. 2, we assume that units of variable factor are homogeneous or equally efficient and are increased one by one. Thus, the law of variable proportions and diminishing returns sets in not because latter units of the variable factor are less efficient than the former ones. It sets in because the ideal factor ratio is disturbed or because the availability of the fixed factor, like machines or land, reduces per unit of the variable factor. 3, and finally, just like for the production function, again we assume that the state of technology does not change. Using the production function, we can understand one of the most famous laws in all of economics, the law of diminishing returns. The law of variable proportions told us that as the factor changes, the return to factor is variable. Now, since the return to a factor eventually always diminishes, we can also reframe it as the law of diminishing returns or the law of diminishing marginal product, which is very similar to the diminishing marginal utility we've already seen for the consumers. Under the law of diminishing returns, a firm will get less and less extra output when it adds additional units of an input while holding other inputs fixed. In other words, the marginal product of each unit of input will decline as the amount of that input increases, holding all other inputs constant. The law of diminishing returns expresses a very basic relationship. As more of an input such as labor is added to a fixed amount of land, machinery or other inputs, the labor has less and less of the other factors to work with. The land gets more crowded, the machinery is overworked, and eventually the marginal product of labor declines. Let's look at a table again to illustrate this. With factor 2 fixed at 4 units, the table shows us the TP, MP1 and AP1 for different values of factor 1. We see that up to the employment level of 3 units of factor 1, its marginal product actually increases. And then it starts falling. Such diminishing returns are a key factor in explaining why many countries in Asia and Africa are so poor. Living standards in crowded Rwanda or Bangladesh are low because there are so many workers per acre of land, and not because farmers are ignorant or fail to respond to economic incentives. When there are so many workers, the MPL of the workers will be low. And later we will see when discussing the labor markets that when MPL is low, the wages or W received by the workers also will be low, which in turn means low per capita income and poverty. Can we use a more everyday example to illustrate the law of diminishing returns? Do you know that you are also a producer sometimes? When you study, you are converting inputs like time and effort to the output of learning and eventually maximizing marks. Now, if you consider your learning, you might find that the first couple of hours of studying economics on a given day is very productive. You learn interesting new laws, facts, insights, etc. The third hour might find your attention wandering a bit, with bit less learning happening. The fourth hour might show that diminishing returns have set in with a vengeance, and by the next day, whatever you produced or learned in that fifth hour is a blank in your memory, unless you revise well. Keeping this in mind, can you explain with the law of diminishing returns why the hours devoted to studying should be spread out rather than crammed into the day before the exams? In spite of the MP coming down as we saw, an increase in the amount of one of the inputs, keeping all of the inputs constant, still generally results in an increase in total output or TP. Have a look at the table to see how the TP changes as the amount of factor 1 increases. We can now make a curve out of this data called the TP curve. The TP curve is a positively sloped curve. This is the shape of the total product curve for a typical firm. Here, we measure units of factor 1 along the horizontal axis and output along the vertical axis. So, if we mark a point here, it would mean that with x1 units of factor 1, the firm can at most produce q1 units of output. So, that is what the TP curve looks like. Now, let's see how the MP curve would look like. According to the law of variable proportions, the marginal product of an input initially rises and then after a certain level of employment, it starts falling, right? This means that the MP curve in the input-output plane looks like an inverted U-shaped curve, going up and coming down again. Now let's see what the AP curve looks like. For the first unit of the variable input, we can easily see that the MP and the AP are the same. Now, as we increase the amount of input, the MP rises and AP, being the average of marginal products, also rises. But it rises less than MP. Then after a point, the MP starts falling. However, as long as the value of MP remains higher than the value of the prevailing AP or average, the latter continues to rise. Once MP has fallen sufficiently, its value becomes less than the prevailing AP or the prevailing average, and then the latter or the AP also starts falling. So the AP curve is also inverse U-shaped, but it is flatter than the MP curve as you can see here. Can you see from the graph that as long as AP increases, it must be the case that MP is greater than AP? Otherwise, AP cannot rise, right? Because AP or the average will only increase if the MP of the next item is more than average. Consider a school classroom. Imagine there are 10 students in the class with these heights. Let's say a few students are getting added to the class. If the height of the next student is more than average, what happens to the class average? It increases, right? But what if a student shorter than the class average joins? Immediately the average of the class comes down, right? Same concept here also. And just like this, in this part of the curve, when the AP falls, MP has to be less than AP. It therefore follows that MP curve cuts AP curve from the above at its maximum point. Why does MP always cut AP curve from the above? We will discuss that a bit later. The AP of factor 1 is maximum at x1. To the left of x1, AP is rising and MP is greater than AP. To the right of x1, AP is falling and MP is less than AP. So important point to remember here, the AP and the MP curves coincide at the maximum point of the AP. Let us now represent the law of variable proportions at work in Chandra's farm. First in a tabular form and then in a diagrammatic form, and see the relations between TP, MP and AP. As we can see here, as more and more units of labor, the variable factor with land held constant are used, MP tends to rise till this point, where 3 units of labor are employed in the farm. In this phase, TP or total product is rising at an increasing rate. This is the phase of increasing returns to a factor. But once a 4th worker is hired, that is, with the application of the 4th unit of labor, a situation of diminishing returns sets in. MP starts decreasing and TP is now increasing only at a decreasing rate. By the time we reach here, with the addition of the 7th unit of labor, the diminishing MP has come down and reduced to 0. The total output is maximum or 15 at this point, when marginal output is 0. Because from this point onwards, every addition will be negative and actually subtract from the TP score till then. Eventually, MP may be negative as people get too crowded on the farm and start harming the crops by stepping on them, etc., since they have no place to work. So now the TP starts declining as from 15 to 14 when the 8th unit of labor is employed. One thing to note here in the table, see this overlap of the brackets here, where MP stops increasing. From that very point, it starts diminishing. Thus, this overlapping is indicated here when MP equal to 4. Let's sum this up now. When MP is increasing from 2 to 3 to 4, TP is increasing at an increasing rate. Why? As you can see, initially 2 units are added to TP, then 3 and then 4 units of output are added to TP, and so TP is increasing. We can call this stage 1 till the MP maximum point. So stage 1 is a stage of increasing returns. When MP is decreasing from 4 to 3 to 2 to 1 here, TP is increasing but at a diminishing rate. Addition to TP reduces from 4 to 3 to 2 to 1 unit. So TP growth rate slows down. We can call this stage 2 and it extends till the MP equals 0 point. This is the stage of diminishing returns. When MP is 0, there is no more addition to TP after that point. Hence, TP is maximum when MP equals 0. When MP is negative, TP starts declining as each unit subtracts from it. We can call this stage 3 starting from MP equal to 0 onwards. It is also the stage of negative returns. We can now illustrate these stages by plotting the points from the table onto a graph. Stage 1 is between O and K on the TP curve. In this zone, MP is increasing and TP is increasing at an increasing rate. K is the point of inflection where TP stops increasing at an increasing rate and instead starts increasing at a decreasing rate. This also corresponds to E here, which is where MP was maximum. Stage 2 is between K to T. In this zone, MP is decreasing and TP is increasing at a decreasing rate. Stage 3 is beyond point T, which corresponds to S, where MP has become 0 and is negative from there on. From here, TP starts declining because MP is negative. So the figure shows us that MP tends to rise till OL units of labor are used, and this corresponds to point E on the MP curve. This is a situation of increasing returns to a factor. When MP is rising, TP tends to rise at an increasing rate. This occurs till point K on the TP curve. This corresponds to a situation of increasing returns to a factor. Beyond OL units of labor, MP tends to decline and TP increases only at a diminishing rate. This occurs between E and S on MP curve and between K and T on the TP curve. This corresponds to a situation of diminishing returns to a factor. When employment of labor exceeds OS units, MP actually becomes negative. Accordingly, TP starts declining then. This is a situation of negative returns to a factor occurring beyond point T on the TP curve and beyond point S on the MP curve. Let's quickly try out our understanding once. Would you agree if I said that TP can increase even when MP is decreasing? Yes, TP can increase even when MP is decreasing, right? Because MP is an addition to TP. When MP is decreasing, only the addition to TP is decreasing, not the TP as such. TP continues to increase, though at a diminishing rate. TP starts declining only when MP is negative in stage 3, correct? Let us now explore in a bit more detail the relations between TP and MP first and then AP and MP. See this schedule and diagram. Here, MP is clearly increasing till 3 units of labor are employed. Accordingly, between O and K, TP is increasing at an increasing rate. Between 3 to 7 units of labor, the MP is declining. Accordingly, between K to R, TP is increasing at a diminishing rate. When 7 units of labor are employed, MP becomes equal to 0. Accordingly, at the point R, TP is maximum. Beyond 7 units of labor, MP actually becomes negative. And accordingly, beyond R, TP starts declining. Now, based on this, we can make some observations about the relationship between TP and MP. 1. So long as MP is increasing, TP is increasing at an increasing rate. We can see here that till the 3rd unit of variable factor, MP is increasing from 6 to 14 to 28 tons of wheat. Accordingly, while the first unit of labor contributes 6 tons of wheat to total output, second unit contributes 14 tons and the third unit contributes 28 tons, implying that TPL is increasing at an increasing rate in this stage. 2. When MP starts diminishing, TP increases only at a diminishing rate. This starts happening when the 4th unit of labor is used. MP of the 4th unit of labor is 24 tons of wheat, and the 5th unit it is 8 tons of wheat, and for the 6th unit it is just 4 tons of wheat. Accordingly, when the 4th unit of labor is used, TP increases by 24 tons. When the 5th unit of labor is used, TP increases by only 8 tons, and when the 6th unit of labor is used, TP increases only by 4 tons, implying that TP is increasing but only at a decreasing rate at this stage. One application here, do you think TP would decrease in a situation of diminishing returns? Answer, no. TP should not be decreasing in a situation of diminishing returns. In a situation of diminishing returns like what we just saw, only the MP decreases, like from 10 to 9 to 8, etc. It means less and less units of output are being added to the TP. Nevertheless, TP must be rising. The TP decreases only in a situation of negative returns. In the same way, do you see that rising TP would not always point to increasing returns? Because TP rises even when MP is decreasing, as in a situation of diminishing returns. The only difference is that in a situation of increasing returns, TP rises at an increasing rate, while in a situation of diminishing returns, TP rises at a diminishing rate. 3. when MP equals 0, there is no further addition to TP. It happens when the 7th unit of labor is used here. So corresponding to 0 MP, TP is maximum. 4. When MP is negative, TP starts declining. It happens here when the 8th unit of labor is employed. TP diminishes from 84 to 80 and MP from 80 to 84, which is -4. MP, as you can see, is the rate of TP. Increasing MP implies that TP is increasing at an increasing rate. Diminishing MP implies that TP is increasing at a diminishing rate. 0 MP implies that TP has stopped increasing. Negative MP implies reduction in TP. Now, geometrically, MP and TP show the following relationships. 1. Increasing MP means steeply increasing TP. 2. Constant MP means TP is rising as a straight line with a constant increase. 3. Declining MP means flatter but still increasing TP. 4. 0 and negative MP onwards, we can see that the TP declines and the shape changes. Now, let's see relations between AP and MP. 1. As we have seen before, AP increases so long as MP is greater than AP. It happens till point A, where AP is at its top or maximum. Note here that AP may continue to rise even when MP starts declining. Why? As we know, this happens so long as the declining MP is greater than the existing AP. So when MP here declines from 28 to 24, when the 4th unit of labor is employed, yet the corresponding AP increases from 16 to 18. This is simply because even when MP declines to 24, it is still greater than the existing average product, which is 16, right? Where 3 units of labor are being employed. And hence, the average moves up due to this addition, right? 2. AP decreases when MP is less than AP. It happens beyond the point A, where AP is at its top. 3. AP is at its maximum when AP equals MP. It is exactly at the point A in the figure. Thus, MP curve cuts AP curve from its top. Let's pause here for a moment. Can you see now why the MP curve would always cut the AP curve from the top? This is because when AP rises, MP has to be greater than AP. And when AP falls, MP has to be less than AP. Accordingly, it's only when AP is constant at its topmost point that AP becomes equal to MP, implying that MP curve cuts AP curve from its top. That is, MP has to meet AP from the top. It cannot meet from below because until they meet, MP is always more than AP, right? 4. MP may be 0 or negative, but AP continues to be positive. So there are basically 2 parts to this diagram. This side where we have increasing returns to factor, and beyond this point where we have diminishing returns, right? But what causes these? The increasing returns to factor in stage 1 occur because of the following factors. 1. Fuller utilization of the fixed factor. In the initial stages, fixed factors such as machine and land remains underutilized. See here, this much portion of the land is not tilled when Chandra employs only 1 worker. Its fuller utilization calls for greater application of the variable factor, that is, more employment of labor. Hence, initially, so long as the fixed factors remain underutilized, additional units of the variable factor add more and more to the total output, or marginal product of the variable factor tends to increase. Second reason is division of labor and increase in efficiency. Additional application of the variable factor like labor enables process-based division of labor. Specialized workers may be used for different processes of production. For example, in a farm, Chandra might employ these workers for the actual tilling and have these workers for clearing the land or for fetching water, etc., so that their time is not wasted and is utilized. Similarly, in a factory, we can have workers specializing in various areas, operations, and machines. This is specialization. This increases efficiency or productivity of the variable factor as each factor is employed properly without wasting time or skills. And accordingly, marginal productivity tends to rise. Third is better coordination between the factors. So long as the fixed factor remains underutilized, additional application of the variable factor tends to improve the degree of coordination between the fixed and variable factors. As a result, marginal product increases and total product increases at an increasing rate. Now we come to causes of diminishing returns to a factor. What about these two stages where return starts to come down? Such diminishing returns to a factor or the law of diminishing returns may be explained in terms of the following factors. 1. Fixity of the factor. Fixity of the other factor is the principal cause behind the law of diminishing returns. As more and more units of the variable factor are combined with the fixed factor, the latter gets excessively utilized. It suffers greater wear and tear or becomes utilized in more and more inefficient manners, and hence the diminishing returns. 2. Imperfect factor substitutability. Factors of production are imperfect substitutes of each other. More and more of labor cannot be continuously used in place of capital. Accordingly, diminishing returns are bound to set in if only the variable factor is increased to increase output. Basically, this means that if the ratio of factors is not optimal, substituting for the fixed factor with more of variable factor will not help. We know there is always an ideal factor ratio. What happens if this ideal factor ratio is crossed? If the ideal ratio is crossed, diminishing returns to that factor sets in. MP of the variable factor starts declining. TP increases only at a decreasing rate. Third is poor coordination between the factors. Increasing application of the variable factor eventually disturbs the ideal factor ratio. This results in poor coordination between the fixed and the variable factors as well as among the variable factors themselves, as you can see in this crowded farm where no one is able to work properly. Hence again the diminishing returns. Now, as we saw, the law of variable proportions illustrates the three stages of production, also called the three phases of production. Stage 1, when MP is increasing, is called the stage of increasing returns. Stage 2, when MP was diminishing, is called the stage of diminishing returns. And stage 3, when MP is negative, is called the stage of negative returns. What is the significance of these stages of production? The main idea is to see how producers react to these stages. Will a producer like Shyam or Rohit stop in stage 1 of production? No, because in stage 1, employment of every additional unit of the variable factor, other factors remaining constant, is giving more and more marginal output or MP. Will a producer ever enter into stage 3 of production? Again, no, because in stage 3, employment of every additional unit of the variable factor, other things remaining constant, is actually causing loss of total output because MP is negative. In fact, it is foolish to get into a situation where total output is declining even when the cost of production is rising on account of additional employment of the variable factor. A smart producer like Rohit or Shyam would never keep employing people to get into the negative MP category. Now remember, every firm is trying to minimize cost, so they won't unnecessarily be hiring people. And this brings us to the conclusion that a producer will produce only in stage 2 and stop ideally at its end where MP becomes equal to 0. Technically, this means that a producer will find his equilibrium where he maximizes his profits only in stage 2 of production when MP is declining but is still positive. All the concepts we saw till now, like variable proportions, diminishing returns, marginal products, etc., refer to the response of output to an increase of a single input when all other inputs were held constant. We saw that increasing labor while holding land constant would increase wheat output in a farm by ever smaller increments, as per the law of diminishing marginal product. But sometimes we are interested in the effect of increasing all inputs, that is, seeing what happens when all inputs vary simultaneously. For example, what would happen to Chandra's wheat production if land, labor, water and other inputs were increased by the same proportion? Or what would happen to the production of cars if the quantities of labor, computers, robots, steels, and factory space are all doubled? These questions refer to the returns to scale or the effects of the scaling up of all the inputs on the quantity produced. Three important cases or scenarios occur when we change the scale of all factors. 1. Constant returns to scale. This denotes a case where a change in all inputs leads to a proportional change in output. For example, if labor, land, capital and other inputs are doubled, then under constant returns to scale, output will also double. Many handicraft industries such as handloom industries and cottage industries show constant returns. Constant returns to scale, CRS, is a property of production function that holds when a proportional increase in all inputs results in an increase in output by the same proportion. Second is increasing returns to scale, also called economies of scale. This arises when an increase in all inputs leads to a more than proportional increase in the level of output. For example, Shyam might find that increasing the input of labor, capital and raw materials by 10% will increase the total output by more than 10%. Increasing returns to scale, IRS, holds when a proportional increase in all inputs results in an increase in output by more than the proportion. Information technologies often display strong economies of scale. A good example is Microsoft's Windows operating system. Developing the Windows Vista version reportedly required $10 billion in research and development, beta testing, and promotions. Yet, the cost of adding Windows Vista to a new computer is very close to zero because doing so simply requires a few hours of computer time. We will see that strong economies of scale often lead to significant market power to some firms. Third is decreasing returns to scale, also called diseconomies of scale. This occurs when a balanced increase of all inputs leads to a less than proportional increase in total output. In many processes, scaling up may eventually reach a point beyond which inefficiencies set in. These might arise because the cost of management or control became too large. One such case has been observed in electricity generation, where firms found that when plants grew too large, risk of plant failure also grew too large. Many activities involving natural resources such as growing vine grapes or providing clean drinking water to city shows decreasing returns to scale. Even agriculture beyond a point is also shown to demonstrate DRS phenomenon, which is why it is often argued that small and medium-sized land holdings are more economically productive than very large land holdings. Decreasing returns to scale, DRS, holds when a proportional increase in all inputs results in an increase in output by less than the proportion. Overall, production shows increasing, decreasing or constant returns to scale when a balanced increase in all inputs leads to a more than proportional, less than proportional or just proportional increase in output. For example, suppose in a production process all inputs get doubled. As a result, if the output gets doubled, the production function exhibits CRS. If output is less than doubled, then DRS holds. And if it is more than doubled, then the IRS holds. Let's consider a production function. Q is a function of x1, x2, where the firm produces Q quantity of output using x1 amount of factor 1 and x2 amount of factor 2. Now suppose the firm decides to increase the employment level of both the factors by T times, where T is greater than 1. Mathematically, we can say that the production function exhibits constant returns to scale if we have function of Tx1, Tx2 is equal to T into function of x1, x2. That is, the new output level function of Tx1, Tx2 is exactly T times the previous output level of function of x1, x2. Similarly, the production function exhibits increasing returns to scale if function of Tx1, Tx2 is greater than T into function x1, x2. It exhibits decreasing returns to scale if function of Tx1, Tx2 is less than T into function of x1, x2. Let's now compare returns to a factor versus returns to scale once. Now let's look at one more concept called productivity. It is one of the most important measures of economic performance. Productivity basically measures the ratio of total output to a weighted average of inputs. Or it can measure per factor productivity as well as a ratio of output to the factor input. Economists typically look at two measures of productivity. Labor productivity, which calculates the amount of output per unit of labor, and total factor productivity or TFP, which measures output per unit of total inputs, typically of capital and labor. When output is growing faster than inputs, this represents productivity growth. If increasing returns to scale prevail, the larger scale of inputs and production would lead to greater productivity. Suppose that with no change in technology, Shyam's firm's inputs increase by 10%, and that because of economies of scale, the output increased by 11%. The economies of scale would be responsible then for a growth in total factor productivity of 1% in this case. A different kind of efficiency arises when there are economies of scope. Economies of scope occur when a set of different products can be produced more efficiently together than apart. One simple way to think about economies of scope is to imagine that it's cheaper for two or more products to share the same resource inputs, if possible, than it is for each of them to have separate inputs. An easy way to illustrate the idea of economies of scope is with rail transportation. A single train can carry both passengers and freight more cheaply than having separate trains, one for passengers and another for freight. In this case, joint production reduces the total input costs. In economic terminology, this means that one input factor's net marginal benefit increases after this kind of product diversification. Let us compare economies of scale and economies of scope funds and see. With that, we conclude our discussion of the production aspect of producer behavior. Now it is time to get into the next three aspects. We will do so in the next chapter when we discuss cost minimization, revenue maximization, and ultimately profit maximization.